Hello guys, again we are on the Delta E telescope. This is the lecture third of the nuclear physics. Again, this Delta E telescope basically this is the combination of two detectors, and this combination is used to identify the type of the particle or the energy of the particle. We can select Delta E out of these three detectors and E also out of these three detectors. Means this is one detector that may be gaseous scintillation or semiconductor. This is another detector that is E, which may be again gaseous scintillation or semiconductor detector. As we have discussed earlier that this delta E is for small energy and this E is for large energy. So in the last lecture we have discussed various type of gaseous detector. Now today we will discuss this scintillation detector. So what is the basic principle and what will be the working of this scintillation detector? We will be discussing the how this scintillation detector will work. So as we know that the nuclear radiations, they will be of two types. One is the charged and other is the uncharged. If you are talking about the charged radiations, they may be alpha particles, they may be beta particles. And these particles are passing through a gaseous medium. They will be producing positive and negative ion, that is the ionization. And these ions they will be collected by the respective electrodes of the detector, and the charge will be collected at the end. And this charge collected will be here, will give us the output pulse, and the size of the pulse again it will be depending on the number of ions we have collected, number of ions we have produced, which will be depending on the energy of the nuclear radiations. When we are talking about uncharged radiations like gamma rays, we will be using this scintillation detector. First, what is scintillation? The scintillation is the phenomenon in which when a nuclear radiation is interacting with particle material, the light flashes will be produced. The particle material is called as scintillator and the process of the phenomena is called as scintillation. Now the gamma rays, they can interact with the material in three ways. One is, the first one is, this is photo electric effect. The second one is Compton effect, and the third one is the pair production. So these are the three ways by which the nuclear radiation will be interacting with the material. One is photoelectric effect, second one is Compton effect, and third one is pair production. All in these three processes, just say if you are talking about this photoelectric effect, the nuclear radiations they are interacting with the innermost cell electron. Here, let us suppose this is the electron. The radiation will be interacting in this way. So the some part of the energy of the gamma rays that will be utilized to liberate the electron, and the remaining part of the energy that will be appearing as the kinetic energy of the electron. So if H nu is the total energy of the gamma rays, then this is the kinetic energy of the electron, or we can say that this is kinetic energy of the electron. This total energy will be appearing as plus this is the binding energy of the electron. So this electron will be removed and this electron will have this much amount of kinetic energy, which will be the H2 minus the binding energy of the electron. Now, so this kinetic energy here, this kinetic energy of the electron here, or we can say that the energy, this energy will be utilized here, or this will be dissipated in the medium, or this kinetic energy of the electron that may be appearing in the form of light flashes. Or we can say that this electron with this much energy is in higher energy state, and when it will loses its energy, then the light flashes will be produced. That phenomena is called as scintillation. In case of Compton, the gamma rays they will be interacting with the electron of outermost cell. Then we will be getting a here. If this is H nu again is the energy of the gamma rays, then we will be getting an electron here, and we will be getting a scattered photon of some lower energy. So this photon again that may be produce another electron by the phenomena of again this photoelectric effect. So whole the energy will be appearing as the kinetic energy of the electron. In the third process, that is the now pair production. In pair production, we will be getting a pair of electron and proton here. The electron, if we are supplying energy here, then the electron will jump from valence band to conduction band. Then a hole will be created in the valence band and electron will be created in the conduction band. This phenomena is called as pair production. So again, the electrons will be produced here. So in all these three processes, that may be photo, that may be quantum or pair production, the electrons will be produced, and the kinetic energy of the electrons, that will be the kinetic energy of the electrons, that will be appearing as the light energy, and this phenomena is called as scintillation. So in case of a scintillation detector, the basic principle is the gamma rays will be interacting with the material by three processes. The electron will be liberated and the kinetic energy of the electrons, then that will be appearing as the light flashes, which is called as scintillation, and the interaction in a particular material, that material is called as scintillator. So this is the basic principle here. Now what will be the various part of a scintillation detector? The various part are the first one is a scintillating material or scintillating material. Here the scintillating material will be this sodium iodide thallium activated crystal. We will be selecting this material due to these properties here. The first one is it has large conversion efficiency, the large amount of energy of the gamma rays that will be converted into light, large thickness, the thickness, this crystal will be grown in a large size so that the nuclear relations may be stopped in the scintillating material. The decay time is lower, जैसे ही आपके radiations gamma rays बढ़ेंगे वैसे ही light flashes आपके produce होंगे. So the decay time is lower. Then this material will have high value of density and this atomic mass number, so that the probability of so that the cross section for photoelectric effect, pair production, Compton effect, that will be large. So these phenomena will occur predominantly in the sodium iodide crystal. We will be adding this thallium here. This thallium is called as wavelength shifter. Wavelength shifter. This will shift because here when the radiation will be entering in the chamber here and they will be interacting with the material, this is sodium iodide, the light flashes will be produced, and these light flashes, they will not be visible later. So the thallium will shift the wavelength of the light flashes which are produced by sodium iodide into the visible layer. So this is called as wavelength shifter. So this is sodium iodide thallium activated crystal. So we will be adding thallium so that the wavelength of light will be shifted in the visible layer. So first part is this is the crystal here, this is scintillating material. This scintillating material, that is sodium iodide, it is hygroscopic in nature. Hygroscopic means this will absorb the moisture from the surroundings. So we will be isolating this crystal from the surrounding. So we will be sealing this crystal by this is aluminum can here. We will be taking a chamber which will be sealed by the aluminum here. So we will be taking this crystal. After that we will be having this is photocathode. The second part is the photocathode. The light flashes, we will be converting the light flashes into the electrical signal, and this will be done with the help of a photocathode. The light flashes which are produced by the crystal here, this is sodium iodide, they will be falling on the photocathode. The electrons will be emitted from the photocathode. This is made of cesium antimony. So these electrons which will be produced by photocathode, they will be entering in a tube, and this tube is called as photomultiplier. This all is called as photomultiplier tube. This is called PM tube. This photomultiplier tube will multiply the number of electrons which are emitted by the photocathode, so that we are getting at the end a signal of large size. So this photomultiplier tube will have large number of electrodes. This is first electrode, second, and so on. At the last, we will be having this anode here. The anode will collect the electrons and we will be getting an output pulse. So these are the diodes here, and these diodes will have a material so that the coefficient for secondary emission of electron will have a large value. So when the first electron will be falling on this first diode, then these electrons will liberate further electrons so that the number of electrons will be increasing. So after each absorption by a diode, the number of electrons which will be emitted, that will be more. So in this way, the number will goes on increasing. At the last, we will be having a large number of electrons which will be collected by this anode. You can see here all the diodes, they are placed with increasing positive potential. This is the higher positive, this is the lower positive. We are putting these resistance here so that the voltage goes on increasing. So at the last, let us suppose if n is the number of electrons which are collected by the anode, then the charge collected will be by, this is of n into E, and the output voltage will be, this is given by Ne upon C, where C is the capacitance of the output circuit. So at the last we have a filter here, then preamplifier, then discriminator, and then we have the scaler. These are the supply for low tension supply for all these preamplifier, discriminator, and scaler. This is the supply for this anode. So this photomultiplier will multiply the number of electrons so that large number of electrons they will be connected at the anode. So the output pulse that will have a size of V is equal to, this is the charge collected by the anode, and this is the capacitance here. So these are the various part of a scintillating detectors. This is first one is scintillating material, then photocathode, then PM tube, and at the last one this electronic circuit, so that we can read the output pulse here. Now, so this is the working of a scintillation detector. We can have different type of pulses in the scintillation detector. That may be the pulses in pass, that may be photo peak, depending on how the radiation will be inflicting. किस तरह से आपकी radiation जो है inflict कर रही है, उसके basis पे we will be having different peaks at the output signal. So we need not to describe these peaks here. We have to only how the radiation will be detected by scintillation detector. So this is the scintillation detector. After that we have the semiconductor detector. Now we will be discussing this detector in the next lecture. So we are having gaseous, then we have scintillation. So we have a brief idea of these two types of detector, so that we can select delta E or E out of these three detectors: gaseous, scintillation, and semiconductor.